So we're going to move into talking about something called combinations. It's very similar to what we did here, but it's a very different concept. If you have 4 different coins, quarter, a dime, a nickel, and a penny in your pocket, and you randomly pull out 2, how many different groups of 2 could you get? Well, you could get a quarter and a dime, right? You could get a quarter and a penny, quarter and nickel, dime and nickel, penny and nickel. And that's everything. But now let's take a look at if we were to do this in the way that we have already learned, right? So, if I take out 2 coins, there's 4 ways I could take out the first one, 3 I could take out the second one for a total of 12 ways, but how many ways do you guys see here? There's only 6. What's going on? Well, let's talk about it. Here's what's going on. This calculation up here is counting this as different than this. But in fact, if I'm just taking 2 coins out at a time, does the order matter in which I'm taking them out? No, there is no order. It's just a group, right? So this calculation up here is including all their reflections. So how can we get rid of these so that we get the real answer, which is just 6? Okay, we divide it by 2, which works for this because there's 2 ways to arrange them. But what if I was taking out 3 coins? Well, you think we divide by 3?
No, divide by 4.
How many? Let me ask you this. Since the order of those 3 things wouldn't matter, right? How can we determine how many ways you can arrange 3 things? How many ways can you arrange 3 things? 3 times 2 times 1. So you would not divide by 3, but you divide by 3 times 2 times 1. Okay? So combinations are a lot like what we just did. It's just like how we divided out the repeating letters. When we're looking at groups of objects and the order of which they come out doesn't matter, well, we're also going to divide out the ways you can arrange those groups. So that's what a combination is. Okay? So when the order doesn't matter, we have combinations. So here's the basic idea here for these. We're going to find the permutation as usual, but since we're looking at a group of objects and the order doesn't really matter, we're going to divide out the number of arrangements from that set. Okay? So this is a formula that's in your book. The top represents the total number of arrangements. Then we divide out the groupings, and that's what the bottom is. I'm not going to use the formula. I'm just going to show you using a few examples here based on the same exact thing we've been doing. So go ahead and write down A for me. Domino's Pizza has 10 toppings to offer their customers, but only let them pick 3 to put on their pizzas. That's obviously not true, but we're just pretending here. How many different pizzas can you create? Well, how we might consider this is, well, I can pick 3 toppings. Now, let's pretend once you pick one, you can't pick it again, like you can't get triple pepperoni. So if you pick pepperoni once, cool. But that leaves how many options for my next choice?
9.
It leaves 9. And then 8. Now, when you're looking at pizza, I mean, is there any order that really matters when you're putting toppings on? I don't want to get into a big philosophical debate about this. Yes, Mr. Bailey, my onions must be on top of my pepperonis. If you're weird, that's okay. But the fact is that the order of the toppings, we're going to just say here, is irrelevant. So, for those 3 toppings, I want to find out how I need to get rid of the order because this creates an order. This is saying that pepperonis, onions, and bell peppers is different than pepperonis, onions, and bell peppers. So the orders are different. And we don't want to take that into account, so we're going to divide it out. So how many toppings do I have? How many ways can you arrange 3 things? 3 times 2 times 1. So I'm going to divide out that many arrangements, which let's see what that leaves us with. 3 goes into 9 3 times, 2 goes into 10 5 times, and that leaves us with 15 times 8, which is 120. Okay. The school is holding tryouts for soccer. 15 kids try out and only 10 will make it. So how many outcomes are possible? Well, here we go. I'm going to show you guys a longer way, but there's a shorter way if we're thinking a little bit ahead of time here, okay? First of all, there's 15 kids, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, wait. We're picking out 10 kids only, right? Yeah. So we only want 10 dash marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we only want 10 hash marks there. Now, how many ways can I pick the first kid? No. I've got 15 kids to choose from. Then there's 14 kids, followed by 13, 12, 11, 10, 9, 8, 7, and 6. Okay? Now we have to get rid of the order, because when a coach is picking a team, it doesn't, I mean, I guess in middle school it kind of sucks when you're the last one called, so I guess order kind of matters. But really, when you have a team, it doesn't matter which names pull out of the hat first. So we're going to ignore the order in which these people are called up. I'm just looking at a group of 10 people. So how many ways can I arrange 10 people? 10. So we have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, and then we can just do a lot of division here. So as you guys can see, I've got 10, 9, 8, 7, 6 here. So these will take all each other out pretty nicely. So I just need to take care of the 5, 4, 3, 2, 1 now. 5 goes into which of these? 15. By the way, it's really important you guys are nice and neat in your work here. If you're messy, you're going to miss numbers. So try not to be messy. 5 goes into 15 3 times. 4 goes into 12 3 times. 3 goes into none of the original numbers, but look, after I divided 15 by 5, what I have? 3. So I could take that 3 out. And 2 goes into which of the numbers? 14. Goes into the 14. 7 times. So that's it. We can ignore the 1. And what I'm left with is a 7, a 13, a 3, and 11, all being multiplied. So if I can get a little calculator help out there. 3,000 and what?
273. Oh, never mind. I didn't actually 429.
273. Did you get the 11 also?
Oh, no.
Yeah, we need the 11.
3,003. My bad. I didn't 11.
Are we in agreement?
Yeah.
Okay. Okay, so I'm going to let you guys try some. There you go.